All right, you guys. So we've been talking a lot about linear equations lately. Last time we talked about vertical and horizontal lines. Today we're going to talk about parallel lines, right? And what is special about them, right? So this is literally the only topic we're talking about today, but it's going to bring in a ton of skills that we've been talking about for the last 2 to 3 weeks. Okay, so here we go. We've got, obviously in this picture, in this graph right here, we have two parallel lines that are being graphed. Just in case you don't remember, there's the definition of parallel lines, right? Lines that will never cross each other. So what we want to do is we have line A, which is the red line, and line B, which is the blue line. So it says, what is the slope of line A? Right, line A being the red one. So I need to go find some points that I can identify pretty easily. So it looks like this point is on there, and then this point is on a corner. I mean, obviously there's infinite points, but I'm just trying to find ones I can identify that are nice, pretty integer or whole numbers, so that I can find my slope. So it looks like we are going up 3 and over 1, right, to get from one point to the next, or one major point to the next, right? Up 3 over 1, up 3 over 1. I can definitely see that that is continuing, right? So I'm going to say that the slope of this line is up 3 over 1. Remember, slope is rise over run, or of course we could just write that as 3 instead of 3 over 1 if we want to, since 3 divided by 1 is 3. All right, then we're going to go find the slope of line B. All right, so I'm going to go find points on him. Let's see. That looks like a major point there, major point there, and so on and so forth. And if I just go from any one point to the next, it looks like, oh yeah, I'm going up 3 and over 1. Right, what a coinkydink, right? So it looks like the slope of line B is also 3 over 1, or just 3. All right, so of course, what do we notice about our slopes of these two parallel lines? All right, they have the same slope. Right, and of course, this is true of all parallel lines, and that should make sense, right? Isn't the only way that two lines can never ever cross one another is if they are increasing or decreasing at the exact same constant rate, right? So of course their slopes have to be the same, right? If their slopes were different, then they would eventually cross somewhere. Okay, so this is basically all we're learning today, right? That parallel lines have the same slope. Now we're just going to prove that or show that in multiple different ways. Okay, so here we go. This first one is a set of graphs, right? Determine if the lines are parallel or not. All right, so obviously we need to find the slope, right? So again, I'm going to kind of go up, find some major points that are on corners, and it looks like that is a continuous up 2 over 1. And I'm going to mark this as line 1 because they're not marked. So slope of line 1 up 2 over 1, or just 2. And then the slope of line 2, I'll make this one 2. Let's see, it looks like it's going through here, and then here, and then here, and then here. Like, oh yeah, that looks like it's also up 2 over 1, or just 2. So are these two lines parallel? Yes, they are, right? Because they have the same slope. Okay. Obviously, you can tell visually whether things kind of look parallel, but we have to prove it, right? So you just can't say yes because they look parallel, right? Clearly, these two do not look parallel, but we have to prove that. You just can't say no, right? In math, you have to prove your response, right? So I'm going to call this top line line 1. So it looks like it's passing through here. I'm just going to keep rolling until I find other points. There we go. So it looks like on this one, we're going up 1 over 3. So our slope would be 1/3. And then on line 2, I'm going to make the bottom one line 2. It doesn't really matter which one is which. Let's see, I'm going to go up, over, up, over, up, over. And it looks like I'm consistently going up 1 over 2, up 1 over 2, up 1 over 2, etc. So his slope is 1/2. All right, so are these lines parallel? No, right? They're definitely not parallel, right? Because their slopes are not exactly the same. Now, 99% of the time, we are not going to be giving you guys graphs, right? So most of your information is going to be non-graphical. So let's kind of look at those questions. Oh, and I totally forgot to space these notes out. Oh man, I did not leave you guys a lot of room here. I am so sorry. I totally meant to space those out before I printed off your notes. That is so my fault. Okay, so determine if the lines are parallel, show proof. All right, well, you'll notice none of these are graphs, right? So that means that we are going to have to identify the slope of the line based on whatever information we are given. So it looks like on this first one, this number 3, they gave us linear equations. So you have to ask yourself, what form is the linear equation written in, right? So it is very clear that this first line is written in y equals mx plus b form, which we are uber familiar with, so that's awesome. And we love y equals mx plus b form because it does provide us with the slope, right? So I know the slope of this first line is 4, right? Then I'm going to go over here to the second equation. Luckily, he is also written in y equals mx plus b form, which does provide us with the slope, so no further work needed, right? So m equals 4 is his slope. So are the lines parallel? Yes, they are, right? That's really it, right? This one didn't require any work because they were already provided to us in slope-intercept form, which is super awesome. And that's, of course, not always going to be the case. Okay, let's travel over here. It looks like these are also in y equals mx plus b form, right? So again, very easy to identify our slopes, right? So this guy has a slope of 1/2. This other line is also written in y equals mx plus b form, right? So his slope is 2. I'm going to write that down. All right, so I've got a slope of 2 and I've got a slope of 1/2. Those are definitely not equal, right? So this is no. These two lines, if I were to graph them, they would clearly not be parallel, but I don't need to graph them. I know they're not parallel because they don't have the same slope. All right, let's move on to number 5. Again, I'm so sorry. I did not give you a lot of room here. That was so not my intention. So let's take a little notice here that neither one of these are written in y equals mx plus b form. So what form are they written in? They are written in standard form, right? This is ax plus by equals c, which you'll notice I don't see an m anywhere in sight, which means I'm not getting none of the numbers that I see here. None of them are my slope, right? So we have to find the slope by converting it into y equals mx plus b, right? We've literally done this dozens and dozens of times, right? So we should all be very well versed in doing this, right? And so I know that I want to get it in y equals mx plus b, which means we have to get the y all by itself, right? So this lovely y right here, right, we need to get him all by his lonesome, which means the very first thing we need to do is pick up this minus x or negative x and move it to the other side. So literally all I'm going to do is I'm going to write 2y. I'm going to bring down my positive 2y. And when I bring my minus x to the other side, he's going to become positive. And then I'm going to kick my plus 12 out. Remember, when you pick up an entire term and move it to the other side, it must change sign. Okay? That's only when you add or subtract. And you'll start seeing the y equals mx plus b taking shape over here, right? But we're not done because it doesn't say y equals yet. It says 2y equals. So that means we need to do our final step and divide everybody by 2. So obviously those cancel. So we're left with y equals, now please be very careful right here, right? Remember, there's an understood 1 sitting in front of that x, which means this is giving us the fraction 1/2, right? If that 2 is in the denominator, he's got to stay in the denominator. So this is going to become y equals 1/2. I'm going to kick the x out to the side and then plus 6. Again, I'm so sorry. I did not give you a lot of room there. All right. So now that he's in y equals mx plus b form, well, then the whole point of doing that is to identify his slope. And which one of these numbers is his slope? The 1/2, right? So this guy has a slope of 1/2. I'm just going to write that out here to the side because I do not have a lot of room. Okay. All right, so now we know his slope is positive 1/2. Now we need to go over to the other equation and we're going to do the exact same thing, right? So here we go. I'm going to pick up my positive 5x and move him to the other side. So that just leaves us with our negative 10y. Please don't forget that to bring down the negative with the 10y, those belong together. But I'm going to put a negative 5x on the other side because I have to change the sign when he moves to the other side of the equation. And then I'm going to kick my positive 3 out to the far right because that's my constant. Again, notice the mx plus b happening there. And then, of course, our final step is we need to get rid of this negative 10 multiplier by making him a negative 10 divider. Right? And that is going to give us y equals, now we just need to simplify everything. Please notice right here, it's a negative divided by a negative, which is going to give us a positive, and a 5 divided by 10 reduces to 1/2. Use your calculator if you need to. And then this is kind of going to be a mess over here, but we don't really care about what the y-intercept is because today it's just really all about slope. So now that I have him in y equals mx plus b form, I'm like, hey, what's his slope? And clearly his slope is 1/2. Well, my other line also had a slope of positive 1/2. So that means yes, right? These two lines are in fact parallel because they have the same slope. All right, let's hop over to this one. If you want, you can kind of pause the video and try this one all by yourself and see if you can get the correct slopes and the correct answer. Or you can just kind of let it play and listen through, but give you a chance to kind of see if you can do it on your own. All right, so I need to get this guy. He's in standard form, just like the previous problem. So we need to get him in y equals mx plus b form. So once again, I'm going to take this positive 4x, and I'm going to move him to the other side, in which case he has to become a negative or a minus on the other side. So that's going to give us negative 5y equals negative 4x, and then I'm going to kick the positive 10 out to the side. And then, of course, our very last step would be to get rid of that negative 5 multiplier by making him become a negative 5 divider. And that is going to end up giving us the equation y equals, now I can't reduce 4/5, but I can simplify the negative divided by negative. So this is a positive, gosh, I so don't have a lot of room, positive 4/5 x. And of course, 10 divided by negative 5 is negative 2. Again, I don't really care about the y-intercept. My job today is really just finding the slopes of the lines so I can compare them. So this guy has a slope of 4/5. I'm going to just write that out over here. Okay, so we found his slope. Let's go find the other guy's slope. All right, so let's see. I'm going to change colors. All right, so same thing. I need to pick this positive 5x and move him to the other side. So that just leaves me with the negative 4y. And then, of course, when I move the positive 5x, he has to become negative when I move him to the other side. And kick that plus 2 out to the far right. And then, of course, our last step is to divide everybody by negative 4. Let me scooch this up a little bit. There we go. All right, and then that's going to leave us with y equals, again, I cannot reduce 5/4, but I can simplify the negative divided by negative, which does make it a positive. So this is going to be positive 5/4 x, and then this y-intercept would reduce to negative 1/2. But again, all I really care about today is the slope, right? And so this guy has a slope of positive 5/4. All right, so are these two lines parallel? Doesn't look like it, right? This is 4/5. This is positive 5/4. That is not exactly the same. So this is a big no. Okay. All right. The next section of questions is where the given information is telling you what 2 points a line passes through. All right. Well, what can I do anytime I am given 2 points of data? I can find the slope, right? So I'm going to use my handy dandy slope formula. So I'm going to do slope form. I'm just going to put m sub 1 so I know I'm finding the slope of line 1. You don't have to do that if you don't want to. All right, so we've done this formula a bazillion times, right? So we're going to do y2 minus y1, so 17 minus 7. And then negative 2 minus 3. All right, so just make sure you're subtracting the y's on top and the x's on the bottom. And then we need to simplify this. let's see, that's going to give me 10 over negative 5, which is negative 2. Okay, oopsies. So our slope for line 1 is negative 2. All right, let's go find the slope for line 2. So I'm going to label that M2. Okay. Let's see, I'm going to do negative 10 minus negative 2. Again, we've said it a million times. When you're using the formula, you must have the minus sign from the formula and the negative from the 2, right? Creating that double negative situation, and a negative times a negative, right? When they're right next to each other, that's a positive, right? And then on the denominator, we'll have 5 minus 1, making sure we're subtracting in the same order. All right, let's clean that up and see what that gives us. Negative 10 plus 2 is negative 8. And 5 minus 1 is 4. Oh my goodness, I keep doing that. And if I divide, I'm going to get negative 2. Yay, what do you know? My first line has a slope of negative 2. My second line also has a slope of negative 2. So yes, these lines would be parallel if I were to graph them. All right, let's go try this guy over here. Again, if you want to pause the video, you can, and kind of see if you can figure out the slopes on your own to get your calculations right. There is a possibility, of course, right, that you get your calculations wrong, but you still get the answer correct, like if it was a no, but I'll still count it off if you cannot calculate your slope correctly, right? Because we've been doing this now for over 2 weeks. Okay, so we've got to be able to use that slope formula. So here we go, line 1, 9 minus negative 1. Right, we got that double negative situation happening again because we're subtracting a negative, which is actually adding. And then negative 6 minus 4. All right, now we just got to clean up that mess. So 9 plus 1 is 10, and negative 6 minus 4 is negative 10. So it looks like this guy has a slope of negative 1, or negative 1 over 1. All right, let's go find the slope of line 2. All right, let's see. This guy is 9 minus 5 over 5 minus 1. Erase that so I got some space. Let's see, what's that going to give us? 9 minus 5 is 4, and 5 minus 1 is 4, and that gives us positive 1. Well, I like that the numbers are the same, right? But unfortunately, one's a negative and one's a positive, right? So clearly one line is decreasing and one line is increasing, right? So they're definitely not parallel, right? The slopes are not exactly the same, right? Clearly these would be intersecting lines. All right, and then our last couple, just really quick, talking through these, y equals 5 and y equals negative 8, right? So just keeping in mind what we learned last time, what kind of lines are y equals 5 and y equals negative 8 if we were to graph them? If you said horizontal, then you are correct, right? Clearly the slope is 0, right? And it's only crossing the y-axis at 5 and at negative 8. So these would be horizontal lines. So just kind of imagine that in your head, right? If I have a horizontal line up here and then a horizontal line down here, right? Are they going to run parallel to each other? Yeah, right? So I don't really have to do any work here. I just have to recognize that these are horizontal lines, right? And if you want to, you can kind of remind yourself that, oh, horizontal lines have slopes of 0, right? And so that just officially confirms, right, that they do have the same slope, right? All right, and then of course, number 10 over here, y equals 0 and x equals 5. Well, again, just remembering what we've been talking about, what we talked about last time, right? That y equals 0 means it's crossing the y-axis at 0, right? So that is a horizontal line. But x equals 5 is crossing the x-axis at 5, right? And that is a vertical line. Now let's talk about their slopes, right? Horizontal lines have a slope of 0, right? And what about vertical lines? Vertical lines are the weirdos, right? Because they're not functions and they have undefined slope, right? Are those the same slopes? No. And it makes sense. Obviously, they're not parallel lines because one's a vertical line and one's a horizontal line. And if you remember, we talked last time about how that makes perpendicular lines, right? Because a vertical and a horizontal will always meet at a right angle, right? So we had that conversation in class last time. All right, let's go write some equations to finish us off today. We got 4. All right, so here we go. This is where everything we learned in Unit 3 is going to come back to us, right? So the first one, we're starting nice and easy. It says write the linear equation in slope-intercept form. Okay, so I'm going to note that here, that I want my answer in slope-intercept form. So that's y equals mx plus b of the line that is parallel to y equals negative 4x plus 2, but passes through the point 0, negative 5. All right, so we have a lot of information to unpack here because we're not going to actually give you a graph to graph any of this stuff, right? So you have to do it all algebraically. So we want to be parallel to this line. Well, luckily for us, this line is in y equals mx plus b form. How nice, right? And we want to be parallel to that one. Well, what do we know about all parallel lines? They have to have the same slope, right? Well, what is the slope of the line we want to be parallel to? Looks like his slope is negative 4. So we want our new line to also have a slope of negative 4 because we want to run parallel to this guy, right? So I'm going to kind of keep track of that information over here, right? So we want our new line. I'm going to do this on every problem, and you don't have to do this if you don't want to, but we're going to be doing this all day tomorrow as well. So I want my new line to have a slope of negative 4 because I need it to be the same as the guy they gave me. But they also want it to pass through 0, negative 5. So this is my goal on every single problem that looks like this, is I need to figure out what information I know about the new line that they want me to write the equation of, right? So my new line needs a slope of 4, and it must pass through the point 0, 5. Well, do you notice anything super awesome about the point that they gave us, 0, negative 5? I'm hoping you do, because if you notice that that is a y-intercept, right? Yay, I'm put a little smiley face here. Right, when you're given a y-intercept, that's like a gift, right? Because that is the b value. So I don't have to go through point slope form to get to my final equation. I can just go ahead and hop right to y equals mx plus b. So our answer is going to be y equals our slope of negative 4 and our y-intercept value of negative 5. Right, super awesome. It doesn't require a lot of work. You're not going to get very many of those freebies. So you definitely want to take advantage when you see them. All right, now we're going to step it up a notch. It says write the equation of the line in all 3 forms. I'm going to take a quick second, and I'm just going to write all 3 of those forms underneath just as my little reminder. So remember, you're going to have to start in point slope form. You're not going to have an option. And the reason why I know this is because is this point that they gave us, is it a y-intercept? No. Right, so I'm going to have to go through point slope form, which is this lovely guy. And then that's going to convert me into y equals mx plus b naturally. And then from there, I should easily be able to get into standard form ax plus by equals c. All right, so we're going to go all 3 forms, just what we what we took a test on in Unit 3, you guys. All right, so here we go. I'm going to keep track of my info over here. So everything I need to know about my new line. That looks really sloppy. I'm sorry. Let me fix that. I'm going to kind of keep track. All right, I'll go ahead and write the point in there. I know he has to pass through negative 5, negative 6, because they're telling me that, but I also need his slope. Well, it says parallel, so again, same slope. Same slope to this guy. Well, what form is this guy written in? It looks like he's clearly being given to you in point slope form, which you don't need to do any work with that. You just need to recognize, oh yeah, this is point slope form. Sorry, it's really sloppy, which means my slope is right here. Oops, sorry, I meant to highlight there. All right, so that means negative 1/2 is my slope. So if that line has a slope of negative 1/2, then my new line also must have a slope of negative 1/2. So I'm going to go over here. I'm going to put that in my new line box. And there we go. All right. This is all the information that I need. I need to figure out what is the equation of the line that passes through this point with this slope. And that point is not a y-intercept, which means I have to start in point slope form. I do not have an option, right? So here we go. Y minus y1, which is -6, right? Our y coordinate. Notice the creation of the double negative, which I'm actually going to make a big positive, equals -1/2, parentheses, x minus -5. Again, a double negative is being created, so we're going to put a plus sign there. And guys, that's it. That is our point slope form, right? So I'm just going to write that over here. Y plus 6 equals -1/2 times x plus 5, right? That's our point slope form. But now I need to convert him into slope intercept form. Well, we've done this dozens of times as well, right? We need to get it in y. We're looking for this, right? We're looking for y equals mx plus b. So we need to get the y by itself and get rid of the parentheses. But we need to get rid of the parentheses first. So here we go. Let's distribute the -1/2. So I'm going to bring down my y plus 6. And when I multiply everybody by -1/2x, right, that's going to give me -1/2x. And then minus, because it's -1/2 times +5, that's going to give me -5 halves, or -2.5. If you want to write the decimal, since it's finite, that would be okay. Notice the mx plus b, right, starting to take shape as soon as we distribute. The only problem is we have this plus 6 that needs to get away from the y. So we are going to subtract the 6 to the other side. And that gives us y equals -1/2x. Let's see, that's 2.5 and 6. So that looks like -8.5. Or you can put 17 halves, right? So I don't care. Actually, I'll leave it fractional. Sorry, let me just leave it as 17 halves. I don't want to mix, because you know in standard form we can't have fractions or decimals, and I really don't want to have both. So let's just keep everything fractional. Again, please use your calculator, right? If you just type this into your calculator exactly as it's written using the fraction mode, it's going to tell you that it's 17 halves, right? Or you can hit math, enter, enter, and it will convert it back into its fractional form for you, okay? All right, so that is our answer for y equals mx plus b. So I'm going to bring that over here, just kind of doing all my work on the left and then carrying my answers over. All right, and then our last thing is to get it into standard form. So ax plus by equals c. I'm not really sure what happened to my c. I must have accidentally erased it. All right, so remember in standard form, all the x's and y's are on the same side. Okay, so that means I'm going to have to get this negative or -1/2 x to the other side. Well, if I want to pick up a term and move it to the other side, that means he has to change sign. So he's going to become a +1/2 x when I move him to the left. And again, don't forget that -17 halves is what's left over there. Now, this obviously is not my final answer, because standard form, remember the two rules for standard form. It has to start with a positive x term, which it does. It became positive when I moved it over, so that's good. But I can't have fractions. So I need to get rid of this divide by 2. And the only way to undo a divide by 2 is to multiply by 2. But everybody has to get the 2 multiplier, or else you're changing the linear equation completely, right? So you can either type this in your calculator, or you can recognize that the 2 multiplier and the 2 divider cancel each other out. That's literally the only reason why we do that. And then that gives us 1x plus 2y equals, and then these 2's are also going to cancel out, which is just going to leave us with that -17. Again, type this in your calculator if you need to. Just type in 2 times -17 halves, and it's going to tell you that that is 17, or -17. Okay. All right. And then there's our standard form, x plus 2y equals -17. All right. That was a long problem, right? A lot of steps. But again, we're just constantly reinforcing everything that we've been talking about since Unit 3, right? That stuff's not going away. Okay. All right, number 13, write the equation of the line that is parallel to the y-axis and passes through this point. All right, that's a lot to unwrap, so you might want to draw this out. I'm just going to, you don't have to, but I'm going to give a little visual here by sketching out a little graph. So notice it says, let's just break this down. It says parallel to the y-axis. All right, well, here's my y-axis. So if I'm running parallel to the y-axis, right, what kind of line does that have to be? Oh, well, it's got to be vertical if it's running parallel to the y-axis, right? So we're talking about a vertical line, so an undefined slope, right? And they're also saying it has to pass through the point -5, -2. Okay, -5, -2. So if I know I have to run parallel to the y-axis, right, and pass through that point, I know it's a vertical line, and of course, that means it's crossing the y-axis. The x-axis, I'm so sorry. It's crossing the x-axis at -5, and so that is my answer. Right? The equation of the vertical line. And once you think about it, like, you don't have to draw it out. You can just be like, oh, parallel to the y-axis. That means it has to run vertically, which means that means it only will cross the x-axis, which means the -5 is the only number I actually care about, right? And that, of course, is where that is coming from, okay? All right, one more. We're going to do another one where we have to write it in all three forms because you're going to need lots of practice with it. So let's do one more. Again, if you want to pause the video and try this last one all by yourself, and then just turn it back on and fast forward it and see if you got the right answers, I would totally think that was a great idea. This one has quite a few steps, right? So don't get lost in the problem. Just keep your work nice and organized, right? I should be able to follow your work, right? So if your work is like scattered all around the page, right, and I can't follow it, then I can't grade it. Okay, so just keep it nice and organized, just like I kind of did right here, right? I did my point slope, then I converted it to y equals mx plus b, then I took that and converted it into standard form, right? Very fluid, very easy to follow if somebody was trying to read that, okay? All right, so here we go. Write the equation of the line in all three forms that is parallel, okay? That should be the first word that jumps out at me because parallel, again, means same slope, right? And it's the same slope to this line, wah, wah, right? Unfortunately, that is given to us in standard form, right? This is ax plus by equals c form. So I don't actually know what the slope of that line is. It's not 2, 3, or -9. I'll tell you that, right? So we're going to solve for y. I know some of you guys are probably getting to the point where you can just manipulate the equation in your head, but that's totally fine, right? But I'm going to go ahead and show the work on here, right? That we need to solve for this y right here, which means we need to pick up the 2x and move it to the other side, right? So here we go. So this is going to become 3y equals, I'm moving the 2x to the other side, which means he has to become negative or minus. And then I'm going to kick out that -9, right, from right there. And then our last step would be to divide everybody by 3. And of course, those 3's cancel, which is the whole point. And that gives us -2/3 x minus 3. So what is his slope? -2/3. All right, so I'm going to kind of do my little keep tracky thing over here. You don't have to do this, but I think it'll be helpful, especially tomorrow. All right, when we move on to other stuff. So my new line, what do I know about him? I know he has to have a slope of -2/3 because he's got to be parallel to that other guy. And I know he has to pass through the point 9, 1. So here's the information I have to work with now. Okay. So I have a point and a slope. So what do you know? I'm going to have to start with point slope form, right? So there we go. All right. Point slope form, y minus y1. So y minus 1, right? That's our y coordinate, equals our slope of negative 2/3, and then x minus the x coordinate, which is 9. I didn't have any negatives in my coordinates, so no plus signs, right? All right, and that's my answer. I'm literally going to write that over here. Y minus 1 equals negative 2/3 x minus 9. And you're like, why'd you write it twice, Miss Jester? Well, I have it over here because this is my jumping off point to start showing my work for y equals mx plus b form, right? So I need to have it over here anyway because I've got to start manipulating this equation, right, to turn it into y equals mx plus b. Okay, so let's start doing that. So obviously to get it in y equals mx plus b, we need to distribute. These are horrible arcs. There we go. So we have y minus 1 and then negative 2/3 x. And now we're multiplying negative 2/3 times negative 9. Again, if you don't know what that is, use your calculator. It's clearly a negative times a negative, which is a positive, and then 2/3 times 9 is going to give us 6. So 2/3 of 9 is 6. Again, use your calculator if you don't know your fraction stuff. No big deal. All right, and notice the mx plus b starting to take shape, but the only problem is this minus 1 over here. So we're going to get rid of him and bring him over with the plus 1, because if you pick up a term and move it, it has to change sign. So that's going to give us y, oh, I don't want to write in that color, sorry, y equals negative 2/3 x, and then of course 6 plus 1 is just 7. And yay, that gives us y equals mx plus b, so I'm going to bring that over here. Awesome. All right, and then last but not least, we need to get into standard form. Well, standard form needs all the x's to the left with the y's, right? ax plus by. So I'm going to bring that 2/3 x over, which means I have to add it. So he's going to become positive when I bring him to the other side. And we're oh so close, but again, just like the previous problem, he's a positive 2/3 x, which is great, but I can't have that 3, right? And I can't have this divide by 3 action going on. So the only way to counteract a divide by 3 is to multiply everybody by 3. And those cancel out, or you can type it in your calculator, 3 times 2/3, and it'll tell you that it's 2. So we have 2 x's plus, and of course this gives us 3 y's. And then our constant becomes a 21. And that is our standard form. 2x plus 3y equals 21. And yay, we've done it. We've written an equation in all 3 forms, right, that's parallel to that given line, right? It's really not that many steps, right? How many steps is this? Right? 1, 2, 3, 4, 5, right? It's 5 steps of math, right? And all math that we already know or should know, right? So the only difference today is that we are finding parallel lines, so we know our slopes have to be the same, okay? All right, tomorrow we shall talk about perpendicular lines, right? And then just do it all over again, right? So if you are still lacking in your skills of converting between lines or anything like that, go back to Unit 3 and do some of that extra practice. And get yourself ready for Unit 4, okay? All right, you guys, I hope that all makes sense. If not, you are always welcome to come in for tutorials and get a little extra help. All right, see you guys later.